And so finally, speaking of change and change agents, I'm pleased to introduce our first keynote speaker, Andy Haun, the Chief Technology Officer of Microgrids at Schneider Electric. Schneider Electric is a market leader in electric products, systems, and services. And microgrids, as a form of a distributed energy resource, have become an increasingly important way to address reliability and resiliency issues, while perhaps someday being able to provide services to the grid. So how would you electrify a remote village? Ensure that a university has power, or a data center, a hospital? Microgrids are a perfect solution. Andy is responsible for driving the technology roadmaps necessary to align portfolio evolutions and to simplify the deployment of effective grid edge technology. So please join me in welcoming Andy.
Thank you, Norman. So good morning, and I'm going to repeat a little bit, not entirely, a little bit of the message that you just heard about what are the trends and what is happening that's going to drive this what we will call solution using edge resources, and in particular microgrids, to solve this problem that was just previously announced. But I've got to highlight a little bit of the problem first again. So let's move forward here. So when we look at microgrids, we first want to look at the bigger story. And the bigger story, not at the big macro level, as a little bit of what was just highlighted, but more around the tangibles. First and foremost, as was earlier stated, electricity is today in our modern energy economies either flat or slightly declining. Energy is flat as a general use in our modern energy economies due to efficiencies that was highlighted earlier. But what's important to note is, as we look to the future, and especially for you young people, is there's going to be heavy investment in electrification. And electrification, even though the energy is stable or flat, electrification is the transition from fossil-based energy consumptions into electrified means. So we're going to have a big growth in over the next, call it 20 to 30 years, in the infrastructure needed to drive some of this transformation in the electrical economy. So we expect to see a rapid rise, call it a rapid rise, but an increased growth in electrification. The second thing, and that's tied to electrification, is digitization. So digitization, everybody hears about it, says, what is digitization? It's going to change our lives. We all pull out our cell phones and make the big example, look at my life with my cell phone. It's really more than this. First of all, we're putting in a digital infrastructure in place that brings information about how we use energy. Now, is this a new and innovative approach? We've been working on that journey for a very long time. We've got connected products that talk digitally, tell us what energy we're using, how we're using it, when we're using it. We're being overloaded with this information. That's happening, and that's been a journey that's been coming for a very long time. More importantly, is we can now digitally manage the energy that we know about. And in the past, that wasn't so easy. We had large, big breakers or large mechanical devices, things that weren't easily managed to be able to control how you consume it, and you didn't have good cloud analytics or cloud management systems that allowed you to do this in an automated fashion. Today, with IoT, and when I say IoT, I mean current IoT, because IoT has been a conversation we've been doing for 10 years, but in fact, it's only been the last 2 to 3 years that it's been at a scalable level that we could take advantage of it and do some of this digital automation. So digital automation of electrons, digital electrons, is what's available to us today and continuing to increase. And this is done through digital controls that sit on top of production devices like photovoltaic inverters, or generator controls, or circuit breakers, or electronic high-speed switching devices, or products that manage the energy at the end, and the end-use devices that can be turned on and off digitally. And with digital control, allows for very fast, easy, and efficient ways to manage the energy that we're consuming. So digitization isn't just about how our cell phone's connected to our electric bill. It's about how we get information about the energy that's being used, how we put automation systems together to manage it, and then how do we control those devices that produce and consume the energy. And that's digital effects on those products that are making this enabled. Now, we've got energy, we've got electrification of the energy, we've got digital control and automation of the energy, and now the last two big changes here are the decarbonization and the decentralization of energy. And these go hand in hand. We don't always talk about them hand in hand, but they're linked. And what's making them linked is the fact that decarbonized energy resources, photovoltaics, natural gas generators, combined heat and power plants, small wind turbines and or dispatchable wind turbines, these are energy resources that are being put together, bundled, and being sold. Opportunistic people like yourselves have been making opportunity around packaging systems that you can put close to the load. So instead of making and building large central distribution, which we still have and we still need, we're also able to put dispatchable systems together and bundle them in a way that they can be put close to the edge of the grid. So decentralized at the edge of the grid, close to the loads, and decarbonization are linked and being linked by the economic opportunity associated with packaging these systems. So all of this is changing the energy landscape from our traditional solution. And the traditional solution, the historical solution, we all know, was built very successfully and does a wonderful job and gives us good, reliable power. And that was large central generation, large central distribution and transportation systems. And then ultimately, we passed it down to the meter, and you took the electrons that you got from that service, and you used them to run your lives, run your businesses, et cetera. That's changing today. It's changing due to the digital controls and digital systems that are in place to make excellent use of these not large, but dispatchable, integrated, distributed, decarbonized generation resources. And they are being put at the edge of the grid. And it's causing the grid operator to have to deal with two things. Energy that's bidirectional, which is different than what they may have had to deal with 20 years from now, and more importantly, consumers who are managing more effectively the way they use the energy, when they use the energy, and how they use the energy. And it's being driven by this group called the prosumer. And this is what we want to focus on, and I'm going to focus on for the rest of this conversation. This prosumer, the producer-consumer, so no longer just a consumer, but a local producer of energy, is driving this transformation. So we have this system in place. The grid's smart. We've been making a smart grid for 20-ish years. We've been talking about it. We've been building it and making the grid smarter over time. But now we have people using the advantages of the grid and these capabilities at the edge of the grid to do their own energy generation and management in the form of a prosumer. So now let's talk about the prosumer a little bit. First of all, the prosumer producing and consuming their own energy and producing energy that others may be able to produce or may be able to consume. These prosumers are making microgrids. Now, they can also be just putting dispatchable energy on site, but if they want to use that energy, they want to do it in a way that allows them to take advantage of it when the grid's not present. So this is where the microgrid comes in. And I want to highlight a term we're putting out here, the microgrid triplet. So there's three triplets to talk about when we talk about a microgrid. Too many people put definitions of microgrid out there and they become watered down, they're bland, and they don't mean anything to any of you other than the fact that somebody wrote one down. So we want to talk about what it is that the prosumer wants in a microgrid, okay? The first thing they want is they want to solve an integrated energy outcome. They have needs that are cost, so they want to manage the cost of their energy. They have needs that are around resilience, meaning when the grid's not there or they need energy, more energy than they have currently, they want to be able to have access to that energy, and they want to have that energy work for them all the time when they need it, not when it's available. So they want resiliency, they want low cost, and by the way, they also want it to be done sustainably, because we all just heard we have a big problem in front of us. We have a big problem we have to solve today, and this means we want to do it with more sustainable energy generation resources. So this integrated system, a system that solves all three of these together, is critical for the prosumer. They can put one by one to solve these problems, but when they put them one by one, the issue they end up with, the prosumer ends up with, they have systems that aren't serving their total integrated need, and more importantly, they probably aren't working all that well in their own individual need. So putting them together and automating those as a system is key, this integrated energy outcome. So how do you do an integrated energy outcome? So you got three problems you're trying to solve together. The second triplet is a power automation system. You have to have a system that actually treats this problem of the first triplet, meaning an integrated outcome. So how do you do it? You have a system that uses the best of our grid. So it's grid tied, it works with the grid, interacts with the grid, leverages the advantages of the grid, the smart grid and the better grids that we're building today, taking advantage of all of that and using the energy from the grid when it's green, when it's cheap, when it's best, and also producing energy when it's green, when it's best for their own needs, and managing their own energy utilization when it's best. So that chain of grid-connected microgrid is key. Also, when the grid's not there, they want to be able to use those same resources that they've invested in to take advantage of those to be able to continue to do operations, critical operations and essential operations on their site. So what do? We disconnect from the grid, and we run in a grid-islanded mode, okay? And we use these resources that we've invested in at the edge of the grid, all right? And we use them to solve important and critical problems in our businesses when we don't have all the energy that the grid would be providing to us. Now, those are two key operating points. The third one is a transition between them, and we don't talk about this enough, and that's a state where you're actually moving from and away from the grid. And you have to have a power system that does that and does that cleanly and safely. So you have to island, you have to change maybe breaker settings, you have to send protection settings, you have to adjust maybe grounding schemes, you have to adjust the system to allow this transition to occur. So this connection between the grid to an island mode and a transition is a power system automation that runs automatically and treats the first problem of the integrated energy outcome from the power system concern. Then, ultimately, you're trying to accomplish one of these missions of cost, sustainability, and or the resilience question, and you're going to manage the energy opportunity that's in front of you based on energy that you can acquire from the grid, energy that you can locally produce when it's green, when it's cheap, and energy that you use in your loads. And if you can control all of those with digital means, you can make a nice balance of the best, cheapest, lowest cost energy that you can make available into your own operation as end users. So energy optimization is the third triplet. And in the third triplet, there's production and consumption. And we all know we produce an electron, we use an electron. We demand an electron, we have to produce the electron. So to make that more effective, we're going to decouple that coincidence and put it in storage. And this is where energy storage comes in. So I can produce electrons when they're cheap and they're green more, and I can consume them when I need them, when I can do it more intelligently. I can shift in time the consumption, and I can shift in time the production, and I can manage all of that more effectively when I put energy storage in place. So maximizing production, maximizing consumption, and storing is the third triplet. So now we've solved the microgrid problem. So it's not a definition, it's an actual thing people want to have happen on their locations, okay? So this is the treble triplet solution for the prosumer who's put the microgrid in place. All right, how do they do it? Okay, what's it mean to them? Well, let's first start with IoT. So as I highlighted earlier, IoT is something that's kind of new. We've been talking about it a long time, but actually having enough smart connected products with real-time embedded controls in them to actually automate and do things is just been arriving over the past couple years and continues to come along. We get more and more products that are connectable, smart, and controllable. So now with these connectable, smart, controllable products, which is what we put at the bottom of our edge, we call it down here connected products, okay? These are the smart products we're going to run the automation system. Then we're going to put an edge control system in place. And the edge control system is something that runs in near real time, manages the environment, manages how the energy system at a prosumer level has to work. And we don't remote that, we don't send it to the cloud, we don't put cloud analytics to try to run smart things in real time on site. We do that with an edge control. And that's not been new. I mean, this is basically what PLCs and other things have been doing for years. The difference today now with IoT is that we stick analytics, we stick smart algorithms, we put machine learning, as was highlighted earlier, in the cloud, and we use this cloud information to take data from the site, take data from web services that are available to you in the cloud, make smarter choices about how to use the energy, when to buy it, when to consume it, and send those control programs down to the edge controller. So the edge controller then facilitates that behavior. And this is an IoT implementation that achieves a software-defined automation of the energy system for the prosumer. And with that, you can take the best case of what's available from the grid, take the best case of what you're producing and can produce and will produce, and the best way to use the energy based on how you do load management and integrate that system as one complete solution. For us at Schneider, we package this in a called an energy control center to make it easy, so that you're not inventing all of that on your site. We build it, build it in our factory, drop it in, and you put the system in place, and allows you to do this in a very fast, efficient way as an edge control. Okay, so I want to give just briefly here, quick, before we go into the question and answers. First of all, microgrids. Where are they at? Well, we have one at our Boston One campus. This is our global R&D site in North America, in north of Boston in Andover, Massachusetts. We put a microgrid in place here as a opportunity for us to save money and also use it as a microgrid laboratory for people, so we can do kind of a living laboratory of different kinds of technologies and solutions in place tied into our microgrid. But more importantly, it runs a section of our building. And this is important, a section of the building. As a global R&D center in our North American headquarters building, we have customers, clients, investors, people coming from all over the world, coming to do seminars like we're doing here. And this is running in our main first floor of our building, where the microgrid solves a problem of assuring that we have resilient, low-cost energy provided for those events all the time. They're backed up by UPSs, we have solar photovoltaic energy provided, we have a backup generator on site, and we manage all of these generation assets to ensure that the conference center, that our customer laboratories, because we do customer testing of equipment when clients come in, our training centers are all operational in the event the grid goes down. So it gives us resilience, and we do all of that at a cost that was at parity, in addition to the cost that we would have gotten from our retail provider of National Grid. So it's a very straightforward system. You put it in place, it operates, and we don't have to own and operate it. We actually sell it to another retailer, a local retailer here in the Carolinas area, which doesn't have has an operating space or isn't in their operating space in New England. But Duke Energy owns and operates this microgrid on our site, and we pay Duke Energy. So this is another transformation happening in the energy or the energy society about how people are trying to put systems in place that actually manage the end use load that's available to them, even if it's not in their regulated territories. Okay? Same thing is true in a very recent microgrid that we've just unveiled, and this is Montgomery County. Montgomery County, we actually put 2 microgrids in Montgomery County. There's in their public safety headquarters building, where they have their fire, police, and and monitoring systems, emergency monitoring systems all together in the public safety headquarters. And also correctional facilities, 2 microgrids we put in place to run and operate the energy there. It gives them lower cost energy than they were getting from their local utility, and it gives them upgrade in the equipment that they had on place. We built that into the microgrid, and all of that was done as an energy as a service solution as well. So again, you can put these systems in place and you don't have to pay for them out of capital. And prosumers can install them. The systems are easy to deploy because we have now automation from an IoT standpoint that allows them to be easily put in place. And the cost is such that they get advantages of a microgrid and either get lower cost or parity cost for the same solution, but with a much better energy outcome that they're trying to achieve. Okay? So this is the reality of what's happening in the microgrid space in the modern energy economy. What's also transitioning is there's the emerging energy economies, those who don't have electricity or those who are getting electricity or have weak electricity, who are also putting microgrids in place, but for different reasons, because they're trying to stabilize and improve the energy that we have the luxury of using today. The final message I want to state is this is not a replacement of our grid. If we remember in my energy automation system, this is a supplement to our important grid system. We have the luxury of having a very good grid, a reliable grid. What's really changing here is we're, instead of sticking resilience always on the grid, we dial in the amount of resilience we need according to if we're running a data center or we're running an operating theater in a hospital. We put the amount of resilience we need in place to ensure that the operations work, and then we put the rest of the responsibility into the grid infrastructure to give us the reliable power that the grid has been delivering for us for the past 100 years. So this is kind of the message of the microgrid story and the evolution of the microgrid solving the prosumer's need, who's really the prosumer wanting to have the outcome of energy in the new energy landscape. Okay. So with that, I'll stop here. And we'll bring down Sarah Van Vleet, who's going to start us off in a little bit of a dialogue. So for those of you who want to ask questions, want to throw stones or eggs or whatever you want at us and you want to challenge where we're at, have at it. But we're really wanting to have this as an open conversation here at this point. Okay? So Sarah.
Thank you, Andy. So as Andy mentioned, we are going to have a Q&A session. We'll have about 10 to 15 minutes between Andy and I. And then there is a URL down here at the bottom right for the audience to submit questions. We'll try to leave the last 5 minutes or so for questions. Thanks, Andy.
Good.
So thank you so much for kicking off the conference and setting the tone with this new energy landscape. I was wondering if you could talk about microgrids in the context of this new energy landscape. How does the technological development that we're seeing in the solar and the battery energy storage industries impact the microgrid space?
Yeah, I think I didn't really cover that in detail, but really what's important to note is that one of the big drivers of these, quote, distributed energy resources and decarbonized energy resources is the fact that these are now coming down in price based on cost optimization, based on electrification changes that have allowed for, first of all, batteries to be deployed and dispatched at a price point that allows us all to invest in them. You know, traditionally we thought about batteries, lead acid batteries, as something that was a big backup generation asset. Okay, the problem with lead acid batteries, and nobody really wants to talk about it, is if you try to use it to do energy optimization, lead acid batteries would die. Lead acid batteries only have a few hundred deep cycles in them. They will actually fail within a year's time if you tried to actually do a daily energy cycling on that battery. So instead of lead acid batteries, we've now been brought forward in time to an era of the lithium ion category of batteries, not a battery, but a category, a suite of different battery technologies. And in the lithium ion category, we're able to cycle those batteries several thousand times. That means that we can actually put these batteries in place and take advantage of their value proposition and not destroy them in doing so in a very short period. Allows us to use them for energy storage dispatch, optimization, tariff management, all these other kinds of ancillary services that we talk about without having to go in and keep swapping batteries in and out. So battery technology has really transformed our ability to do these things, and the battery cost is now at a point that allows all of us to make that as an investment. Solar, we all know about the solar curve and how far that's come down from a cost standpoint. There are still some optimizations to be made there, but more importantly, when we think about PV, the smart inverters, the way the inverters are working in these energy systems, allowing us to do the digital control of the inverters, makes it easier for us to do that at a microgrid scale. What's important to note is that the grid acts as a big battery. We treat the grid as a big dumping ground of electrons. And honestly, I'm not sure that's the smart thing we should do, but we do that. And while it can help the grid and provide energy when the energy's available, bright sunny days, it can do us wonders. It also means that the grid has to absorb and treat all of this energy in a way that it wasn't normally ready to do so. We can also be smarter about how we run the inverters and how we run the inverters tied to solar energy. And so the technology of low-cost batteries, again, with the smart inverters that we can turn on and off, makes it easier for us to be smarter with the grid. It also allows us to tie it to backup generation when we're disconnected from the grid and have to manage the energy equation at a smaller microgrid standpoint. So smart inverters has helped this solve a problem of overproduction and or time of day production managed with energy storage.
Thanks. So building off of that, can you talk a little bit about the business case for implementing microgrids? So a customer comes to Schneider Electric and they want to implement a microgrid. Is there a financial benefit?
Yeah, so customers have an idea, okay, I've heard about a microgrid, I want to do a microgrid, or can we talk about a microgrid? They didn't wake up in the morning and say, oh, geez, I want a microgrid. They came in with a problem, okay, or came in with a concern or an interest to either reduce the energy cost, or they have suffered a storm event or a natural event that's caused them to have outages that have limited their ability to run their businesses or their livelihoods. So they've come to us and said, hey, I want to solve a resilience problem, I want to solve a cost problem, or I've got sustainability metrics. My CEO is banging on me saying I've got to get better numbers on my sustainability index. And so they come in with one of the problems in the trouble triplet, okay? One of them, and what we do is we tell them, look, rather than solving that one, let's talk about a solution that solves all three of those integrated energy outcomes of cost, resilience, and sustainability. And when we have that conversation, what you end up looking at is the costs of the systems that they would put in place, or the cost of the things that they would want to try to do individually is daunting, and it's really, really expensive. But if we can integrate all that together, and we can do it at a improved cost, or even in just parity, but get all these additional advantages, that's what we're trying to solve for. And that's readily available in different geographies around North America. If you look at the SMILE states of North America, many of those, it fits easily into that category. Islands who have central grids or centralized grids but need additional resilience at the edge, it's easy to put them in place on islands. So there are a number of places where it's actually really cost advantageous to have a microgrid, but it's also in the modern energy economy, in our centralized system, in many locations, a financial benefit to have it.
So you just mentioned some of the different geographies in the modern energy economy, and at the end of your presentation you highlighted emerging markets. Can you touch more on the differences of how you expect microgrids to develop in those two contexts?
Yeah, I get when I have conversations with a lot of companies and interested parties wanting to do business in the emerging energy economies. What happens is they come in and say, well, look, there's these mini grids that are being born, or there's a central grid that's coming, but it's not here yet, and I need to put some energy system in place to solve. I want to put a small data center in, or I want to put a small water plant in, or I want to do some energy demanding solution that doesn't have availability to a central grid at that point, but the grid's coming. And so then people say, what can we do? And then we quickly jump to, well, what do you want to solve for? And it jumps really, really quick to putting some sort of a small island grid solution that looks like a microgrid, but it's not connected to the grid, okay? It's an island grid infrastructure. And it starts there, and they think, okay, well, if I do that, and then my neighbor down the road or another zone, another little village has a need, they could build one, and we'll federate these microgrids. And the problem we have with just talking about federating microgrids is like microgrids are going to pop up and we're just going to have interacted microgrids. Is the problem with that is the wire. There's limitations of what the wires can actually do. So we tend to forget about that. We think about the logic of what they would do, but the wire actually has to move power around. And so a central grid that arrives to there can become that important backbone, just as it is in our modern economy today, become that important backbone by which these federated grids interact. So we end up with a central, think in the future, a central grid starts arriving, and we have microgrids already in place that can tie into that, and then they can become more interactive as a central hybrid microgrid solution. Now, let's take the modern energy economy. Where are we at today? We started with a central grid infrastructure. We have a wonderful central grid infrastructure, and now we're seeing distributed, decentralized energy solutions showing up. We're putting microgrids around them, and we're tying them on to the grid, and that becomes the federated microgrid to grid solution. And guess what? It looks the same in the emerging economy as it looks like in the current economy, okay, or in the modern energy economies. It's just how we're arriving there that's different.
Great. You talked about the emergence of the prosumer. What impact do you see that having on the current utility business model?
This is always the big, this comes up quite a bit. So where does this leave the utility, okay? So the utility, does the utility have a future responsibility to treat microgrids as customers? Well, yes, the future will be, microgrids will be a customer. In fact, many microgrids will be, quote, microgrids in a building, okay? And the customer is currently there, all right? But the customer is going to be behaving differently than they would have done if they just took all of their electrons, delivered at their meter to their site. So in this sense, the relationship between the prosumer and the utility, okay, is one, first of all, an economic and or a functional relationship. And then as microgrids become more deployed, meaning there's many, many more of them available, the utility can take advantage of those as a holistic DER. So people can put DERs in today. They can put PV plants out, or they can stick a wind turbine up. They can put things around and tie them into the utility. And the utility can use them, okay? Or the utility can work with the client on the interconnect responsibilities associated with this. But what's really important to note is a microgrid becomes an active DER or solution that the utility can take advantage of. And the interconnect rules and the regulatory rules have to change to allow for your grid operators to be able to work with that microgrid and treat that microgrid as a controllable asset in their suite of assets. And different than a DER, or different than doing a demand response program where they're turning off your chillers or your HVAC systems, and everybody's going, well, don't do that to me, do that to my neighbor. Okay, I want to sign up for the program, but I don't like it. The microgrid doesn't care. The microgrid will be controllable, and then the ecosystem of the microgrid manages how the energy is treated. And so it makes the impact of that demand response or frequency response program or whatever interesting grid operator services may be available become more readily usable by the end user, because the impact goes down so much because the microgrid manages the system behind that connection to the grid. And that relationship is the one that we expect to see emerge in the future. It's one that we look at from our edge grid controls to our advanced distribution management software suite to be able to help utility operators and microgrid owners make that connection and then interoperability work much more cleanly.
What do you think is the biggest misconception about microgrids?
Microgrids are big, hairy, ugly things, and it took a lot of smart people to put them together, and they're expensive, and we don't like them because, you know, unless I'm really compelled to have to do it either by code because I got a hospital, I got to put some stuff in place, or I got a data center that I got clients that wouldn't even serve, I wouldn't be able to serve if I didn't do it. The context of these microgrids being hard to do and taking a long time and really being kind of this ugly thing that sits there and runs and I don't touch it, or I have to put a lot of resources in to keep it running, that's changed. And that changed in the last 5 years. And it changed through smart analytics in the cloud. It changed through edge controls becoming more smart, and it changed through smart connected devices. And this IoT enablement has allowed us to put these microgrids together. And we put them together, and they make financial sense when we put them together. But unlike former microgrids 20 years ago, when you put them together, and then all of a sudden the energy equation changed from photovoltaics, energy changed from different resources. I have new things I want to put in my system, and nobody touches it because it was such a big, hairy, ugly mess to create it the first time that I leave it there, and I don't want to mess with it, don't want to screw with it, let it run, and I just add things on, and I get less than optimal solutions. So why did I buy this microgrid in the beginning? And this is kind of the mentality that people go through when they think about a microgrid. But now with the simple, easy deployment and easy evolution of the microgrid through IoT-enabled automation, you can make the investment now, and that investment continues to evolve and grow and improve without the big, scary problem associated with how do I go in, do open heart surgery on my electrical system, and do adjustments to this electrical system while I'm still trying to run my business.
Thanks. So I think we'll do one more question and then switch gears to the audience Q&A. And with this last one, we have a lot of students that are in the audience right now, and I just wanted to know, what advice do you have for students who are entering the energy industry in 2018 in this new energy landscape?
So the problems that I highlighted and the problems that were highlighted earlier by Norman, these problems are yours, okay? I'm going to retire. I'm going to retire, okay? And there's been a lot of people made a lot of product technology advancements to enable this to happen. But what you need to recognize now is for you young people coming into this space, first and foremost, this is a big, big problem. It's not a big problem just in emerging energy economies. This is a future problem for us, and it's a future problem not just to solve the climate problem. We have to solve the climate problem, but it's also a future problem for you because it helps bring lower cost energy and electrification that's going to be different tomorrow than it is today, largely because there's a big transformation happening from transportation system being largely fossil-based to transportation being electrical-based. And so from a young person getting into this area, stay in the area, okay? It's going to be hard. It's going to be hard. The problems are hard. The transition of the end user, the prosumer, to make the decisions to move into the new energy landscape, to actually step forward and make these investments. This is not an easy step because it's a lot of us old codgers who have to be convinced. And you're going to have to go through this hurdle to make that transformation happen. So my advice is stay with it, stick with it, and understand that it's not going to be an easy thing. Okay? It's going to be hard, and you're going to have to put effort in at the commercial side, at the technical side, and at the policy and political side, okay, to make all of this occur.
Thanks. That's actually a good segue into our first audience question on the policy side. Are there any legislative or policy barriers to implementing the microgrids you described?
Yes.
Great, next question. Just kidding.
Obviously, there are a number of them. First of all, there are regulators who are regulating the microgrid. Because the microgrid shouldn't be just the prosumer. Imagine the prosumer is going to drive some of this. But the microgrid also is at a community level microgrid at the electrical utility level. So the regulation has to start engaging in allowing utility operators to be much more able to operate and own in their regulated space microgrids. Because who's best for managing energy in our economy, in our modern energy economy, is the people who are doing it today, who know it and understand it today. So while we can bring technologies and solutions to make it easier for individual prosumers to do that, we still have the big solution of our grid in place, and letting our grid operators operate more cleanly in this environment in doing microgrids and letting them do those economically for the betterment of their clients and or their communities is one big regulatory hurdle to overcome, okay? Additionally, we have issues around how do we deal with the kind of the energy management framework at a cybersecurity standpoint, okay? And cybersecurity, we don't talk about it enough, okay? In energy conferences, I do talk about it, but cybersecurity is a big thing we have to overcome, and there are going to be regulations that have to be put in place on what kinds of things we do at the microgrid level, at the DER level, at the central grid level, to ensure that we don't damage the integrity of our grid system through cyber physical attacks, okay? And this is a key one that going to need policy to help drive it, not just an improved policy to help drive it, not just technologists working on it. So I would say those two are kind of the two big transitions that have to occur.
Okay.
All right, are we done?
Zach's given me the signal that we're at time.
We're done.
Do we have time for, let's get just one more audience question and then we'll wrap it up. What, in your opinion, aside from implementation costs, is the biggest constraint or challenge to pushing microgrids into the market?
It's awareness. So again, you've seen what I was talking about, but microgrids, when we think about microgrids, it was always this big problem, a big technical thing to solve, and now it's not. But now it also has to be paid for, okay? So we can technically make it easier for you, and that's what I do, that's what my competitors of ours do to make these things easy to deploy. Now it has to be easy to finance and to fund. And there's a new element out there, the energy as a service, where investors are out there trying to buy load at the edge, okay? And that means they're putting microgrids in place because that's an energy system they can put and buy and manage and take ownership of that asset and the energy production of that asset and basically make money off of it. And so what we have to do is understand that while there's a simplification of the technology, there's also a simplification of the financing of it. And those two coming together makes microgrids something that really no building, no campus, nothing should be produced that isn't already considering starting with a microgrid in its site, okay? And so it's going to the big uptick is going to happen when we think about how it's easy to deploy and how it's easy to finance, and now get it into the hands of the consultants, the architects, the builders who are actually able to use them and put them in every location. Because every location then becomes a usable asset that in the future our grid operators will be able to take care of. So deployment through consultants, deployments through architects built on the fact that now they are financeable and they are all easy and from a technology to put together. This is the big, I would say, transitional hurdle for us to put these out there.
Thanks. Big round of applause for Andy Haun.
Thank you.